I want to call your attention to this term independent system again. We've already worked this problem and figured out what it was on page 173. An independent system has exactly one solution. There are two other kinds of systems that you need to know about, and those are shown on page 174. We have an inconsistent system and a dependent system. So let's take a look first at the inconsistent system. And I think to do this one, I'm just going to go back to the notebook and show you why it is called this particular one. So let me go to my notebook page, and hopefully I don't have another one. So let me clear off a page to work on. And we'll take a look at why this one is a little different. And I believe I'm going to go with my coordinate graph because I'm not sure how this will play out. Let me clear the page. Alright, let's see if we don't have that. So I need a coordinate plane to build up this page, and I guess I'll use this nice pretty one. Let's go ahead and graph these two equations. Alright, and to do that I'm going to need tables of values for each one of them. So let me take the first one, the y equals negative x plus 5, and I'm going to build a little table of values over here. Let's generate some points that we can use for that first equation. So draw yourself a table for your values. We're going to use x and y, and here's the equation that I'm using. And I like to use the intercepts unless I have a reason not to. Yeah, let me just use the intercepts. So when x is 0, what is y? And when y is 0, what is x? And I don't think we even need another point. You can graph as many as you want, but I think if you have the intercepts most of the time, it's fine. So we're going to say when x is 0, y is 5. And when y is 0, so let's move the 5. So we have negative 5 equals negative x. So divide by negative 1, and you get x is 5. That's interesting. So let me go ahead and graph this one. At 0, 5, 2, 3, 4, and 5, 0, 1, 2, 3, 4, 5. So this one has a negative slope. We knew that it would because the x is negative. And let me try. I don't know what that is. It just popped up there. And now it won't go away. Okay. Bring in a negative slope. Try it again. It's close enough. All right, so this is that first equation that we've graphed. So let me do another table of values for the other equation, which is x plus y is 3. And we have, I'm going to use the intercepts on this one as well. So when x is 0, and then when y is 0. So x plus y is 3. And if x is 0, you can see that y is 3. And then when y is 0, x is 3. So up to 3, and then over to 3. This is definitely an inconsistent system because they're parallel lines. They never intersect. And remember, that's what we're looking at, is the intersection. So they do not touch. This is an inconsistent system. If you have an intersection, the point of intersection will be the solution. That's an independent system. In this case, they don't touch at all. That's an inconsistent system. And let me go ahead and give you yet another picture to look at. I need a sheet of paper. This last one I'm going to show you drove me insane. It's not hard or any harder than these. You'll see what I mean. So let me go back to the worksheet and get the example from page 174. This one is called a dependent system. Take a screenshot and bring it over to a graph sheet. And let's see what we can do here. So we have two equations to solve. So I'm going to pick a table of values because I need to graph. Anytime you need a graph, you need some points to put on it. So let's go ahead and choose those same 2 points of x and y. And the first equation is 2/3 x plus 4. I'm going to use my intercepts again. So y, let's let x be 0. So we have 2/3 of nothing. You get your y-intercept. So y is 4. And then you have 0 equals 2/3 of x plus 4. So minus 4 and minus 4. Negative 4 equals 2/3 x. So to get rid of the fraction, you're going to multiply it like so. So the fraction's gone here. X equals negative 12 over 2. So x is negative 6. So let me go ahead and graph this one. We have 0, 4. And then negative 6, 0. And here comes the graph. It does have a positive slope because the x was positive. And you know I missed it, so let's try it. There we go. That's pretty good. So here is the graph of that one. And then we need to do a table of values for the other equation. And I have an xy table for 3y minus 2x is 12. And I'm going to use those intercepts again. So I have 3 times y minus 2 times nothing is 12. So that leaves me with 3y equals 12. And divide by 3. Y is 4. And then 3y minus 2x is 12. We're going to let the y be 0. And so that cancels. So we're left with negative 2. So x is negative 6. Now hopefully you notice these are the same. So the second equation is going to lie right on top of the first one. They're exactly the same line. It's just two ways of saying the same line. This is called a dependent function. I'm sorry, a dependent system. When you have exactly the same graph for both of your equations, you have a dependent system. So let me just review. This is dependent. This is inconsistent. And then the one I love myself is the, where'd you go? I was on an odd numbered page. The independent system, where you have one intersection and therefore one solution. So those are vocabulary terms, but they're still good to know, and it's good practice for graphing. All right, I will see you in the next video for a solution problem, and then we'll talk about different ways to solve other than graphing.